So how many of you were at the last presentation in this room about making macro system with Perl? Yeah, that was pretty cool. And this is kind of along the same theme, although probably not quite as deep, but it's about the same idea of making Perl more useful by eliminating redundancy and repetition. And I recently discovered this fairly new CPAN distribution called Moops. It's written by Toby Inkster. And I was able to use this to do something that I've been trying to do over and over again using different tools, but never quite really succeeding. So I want to sort of go over a brief history of the evolution of my experiences with this sort of thing and what tools have been available. And I want to show you some of the differences between them and what Moops allows you to do, in addition to saying the word Moops, which is funny. So, a very brief history of some of the features that go into this matter of extensibility. When Perl 5 came out, it was automatically extensible. It had an extension system built in, which was new as compared to Perl 4. And that extension system is basically this thing, the use keyword. And if you ever looked up use in Perl doc, you'll know that it's basically just equivalent to this. You have a begin block, you call require, you load whatever this is, usually foo.pm, and then you call this import method. And I think, raise your hand if you knew that already. Yeah, I think most of you did, and I've known that for a while. Raise your hand if you actually have an idea of how this import method actually works. Okay, fewer. And so that's always interesting. It's always kind of interesting to see how deep people want to dig down. Because lots of people know this, but lots of people probably haven't looked at import. And the most common one comes from the exporter module. But import can come from anywhere. You can write your own import. You can get it from there are alternative versions like sub exporter and exporter tiny and a bunch of other ones. Or you can just write your own. As long as it's called import, it'll work. So I want to take a moment to figure out how import actually does its stuff. And it's not that complicated. This is just a method, right? It's called with the arrow syntax, so that's an object-oriented method, which means the first argument is going to be the class name that it was called upon. And the next argument is basically whatever list of parameters shows up on that use line. So if you say use foo, qw, and a bunch of stuff, that stuff is going to be packed into that list. To get the calling package that we actually want to import into, we can just use caller. And the actual import subroutine from exporter does some more complicated stuff to figure out if it needs to go up multiple levels in the call stack. But this is a basic implementation that will work fine. We get our list of arguments from that use line, whatever's left in the add underscore. And then this is all we do. We basically just take those symbols from our package and assign them to the type box in the calling package. And that's all import does. And if you look at the actual importer code in the exporter module, there's a lot of features that it implements. It implements those things with like the export OK arrays and the export tags and all that stuff. And that's all just logic, and it also does some housekeeping for caching and stuff like that. But what it comes down to is basically this. This is how import works. And if you write your own importer, this is basically what it's going to come down to eventually after you implement whatever features you're doing. This will work for one type of symbol. You also, depending on what features you want, maybe if you want to export scalars and arrays, you can support that too. This will export subs. All right, so many details omitted there. But that's been available now for 20 years, since Perl 5 was released. And everybody's been using that, and that's fine. And what we can do with that is, because import is compile time, we can add functions and sort of pretend like they're keywords, right? And a lot of CPAN distributions and core modules do this. You look at list util, it gives you functions like any, which is kind of a complement to map. It just returns a true value if any of the items in a list match a condition, or if that condition is true for any of the items. It looks sort of like a keyword that's built into Perl, but it has some limitations. Here's an example. So let's say we have this package called adder, and we have an import routine here. Maybe it comes from exporter, maybe it's a custom one, doesn't matter. And we just have this function called add2 that just adds 2 to something. All right? And we can use it just as if it was a built-in function, and this will work. We run this code and we get 44, assuming we have say turned on. So that's fine. And in Perl 5.2, or 5.002 in the old versioning system, these things called prototypes were invented. And everybody thought, hey, this is cool, we have prototypes now, although we really don't have prototypes until we call them signatures. But prototypes allowed us to make these kind of fake keywords that sort of look like keywords, but they behave like built-ins, at least when they do, and sometimes they don't. And they can get tricky. Here's one called do block, and we can tell from its prototype that it takes a subroutine and a list. And that list might be empty, but the subroutine is mandatory, and all it does is it gets that subroutine ref and invokes it, passing in whatever's left on the list. And if you look at this code here, this works great, and it's going to just spit out the first 5 square numbers. And that's really nice. But it's not always nice. There are some gotchas here. Let's take a look at a version of this that just takes the subroutine. Raise your hand when you see the bug here. Few of you, all right. It's trickling off through the crowd. So the bug here is this. We've told Perl that we want this do block thing to take a subroutine. And so we said do block, get open brace, close brace, and then another expression. This is a compiler. The reason it's a compiler is because there is no semicolon at the end of that block. You need a semicolon because otherwise Perl is going to attempt to parse this last expression, say second, as a list item on the end of that block, but we've told the prototype that there is no list, it's just a subroutine. So this is a compile time error. It'll tell you too many arguments for this subroutine do block. So prototypes can give us some power to do these keyword-like things, but they're subtle, and this is a fail. So prototype subs, the lesson is really that they only work as expressions. I should say the arguments really only work as expressions. A prototype sub by itself can't be a statement. And that's a major limitation, and there are other limitations as well. Here's another one. Here's something that we take a scalar and then a sum. So you might expect that we can say, all right, here's our do block thing, and I have a scalar there, and maybe I might need to quote it, but I'll try it like that for now. And then we have this block. This is also a fail, and the reason it's a fail is because we can only use that magical block syntax if the prototype has the subroutine as the very first item. This won't work. This is a compile error. We have to do it like this. Or you don't have to use fat comma, you can just quote name. But if you have that ampersand prototype anywhere but the first parameter, you don't get that magical behavior. You have to use an anonymous sub syntax. All right, and that's kind of lame. That makes it basically impossible, to do a class keyword or a method keyword using subroutine prototypes. Although people have hijacked that mechanism, not doing prototypes, but abusing the data structures underneath them to do some sort of stuff like that. So, to rectify this, when Perl 5.8 came around, this little bit of insanity called Devel declare showed up. You can thank Mr. Matt Trout and others. And looking around for him, I don't think, I don't see him here. And this was a major advance because it was the first way that we had that we could really add new syntax to Perl. And this was new. We had source filters and stuff before, but source filters, as we know, are a crazy idea and usually terrible. And Devel declare was a way that we could really interface at a low level with the parser. Here's an example, moosex declare, which gives you a declarative syntax for moose. You can just say class foo, method bar, you can put signatures on that methods, you can have anonymous classes, you can do all kinds of cool stuff. And I think, you know, moosex declare is still not recommended for production use, but people are using it. And you know, it's well tested and it works. But Devel declare is complicated. And I don't know if you've ever tried to implement a custom Devel declare syntax. I did not succeed. You know, there's this weird stuff, declarators, scope injectors, method shadowing. I still don't know how that works, even after reading the documentation and trying to read the code. And you know, it's just it's an impressive piece of engineering, but it's not really for mere mortals like me. And I've tried multiple times. It's big, it has a lot of dependencies, it's slow, and it's difficult to extend. I once tried and failed to make the moosex declare class keyword do some custom behavior that I wanted, and I couldn't get it to work. So Perl 5.12 came along, and now we had a keyword API in the core Perl interpreter. And this is new because instead of doing these crazy hacks on the parser itself, the Perl API actually gave us a couple functions for injecting new keywords during compile time. And the nice thing about this is there's a very nice, very simple pure Perl interface to this called keyword simple. And here's an example. I have my keyword. It has a custom import sub. And all it does is it calls this keyword simple define to define a keyword called class. That has a subroutine, and that subroutine gets a reference to a string containing the code that comes after that keyword, which means you can then inject whatever Perl code you want into that string. Munge code there would be some function for munging it. And that works, and it's fun. You know, and at a basic level, it's kind of like a source filter, but not really, because it's a little better because you're hooking onto actual keywords and using the Perl parser, and you have some parser methods available to you. But it's not, you know, it's not 1,000 times better than a pure source filter, but it's a little bit better. All right, so what is Moops anyway? So Moops was written by Toby Inkster. It was inspired by things like moosex declare, except instead of being built on Devel declare, it's built on the new keyword API from 5.12. And actually, I think the minimum version dependency for Moops is 5.14 because it uses some extra thing. Mm-hmm. So here's an example of defining a role, and here's a class that consumes that role. It's very simple. So it's just like moosex declare, but not exactly. For one thing, it uses moo by default, but it can use moose. And in fact, it can also use mouse, although I don't think that's officially supported. But the nice thing about this is it's not tied to one object framework. It does this stuff independently of the object system. Keyword simple is used for the new syntax, as well as some fairly well-tested code for parsing out things like bare word class names and role names and things like that. If you've ever tried to come up with the regex for parsing out a Perl package name, it's actually harder than you think. Uses another Toby Inkster module called Kavorka to do the function and method keywords. And it's designed for easy extensibility, and I'm going to show you that in a second. So about a year ago, I decided I was fed up with certain things. I really like imports. I love getting everything I can from CPAN modules, but I hate boilerplate because every Perl module that I wrote, I had to have, you know, just use this, use that, use all these other things, and I wanted it, you know, all in one place, so I didn't have to repeat myself. So I did this thing. I created a module called setup, and I used this cool module called import into, which basically just takes a class name and lets you import stuff from here over here. And I loaded a bunch of all, you know, the utility stuff that you want to import all the time, as well as, you know, pragmas like auto die and use open, so I can get UTF-8 file handles by default and stuff like that. Here's my custom import method. And all I do is I say scalar util, call this import into thing, and get blessed and ref adder and whatever I want, list util and so on and so on. I didn't actually do it in this repetitive way. I eventually just factored this out into a data structure and then just looped over it to call all my imports with all the arguments, and that works fine. Unless I want to use this in conjunction with some custom syntax, something like Devel declare. So let me show you an example of what I mean. So here's Moops X declare, or it could be Moops, the same issue applies. All right, and I say class myapp thing. And then inside that class, I have to use my setup to get all of my imports, all of my custom stuff and pragmas. And so this always looked kind of ugly to me. And it's a better solution than just copying and pasting everything. But I have to do 2 uses to get everything set up. The reason is I can't just do use my app setup up top because that's still in the main package. You don't get your class package until the class keyword comes. So doing the my app setup up there would just import all that stuff into main, and then once I get inside my class, that stuff would disappear. So in other words, I have to use the setup class from within the right namespace to get it to work. But what if my setup class could also inject custom syntax? Then I would have the best of both worlds. So here it is. The nice thing about Moops is it's designed to be really extensible. This is one way to extend it. I'm inheriting from Moops here. I have a custom import method. And all I have here is just an array mapping class names that I want to import from to the list of things that I want to import. You have to make sure these classes are loaded first. And then all I do is I just call the parent class method. This is Moops' import method, passing it this list of imports, and it's done. So now I can actually use Moops, or not use Moops, but use my app setup. That loads Moops. Then I'll automatically have the class and role and all the other stuff that Moops does, plus all of my custom stuff. So now I have basically a completely customized, configured Perl, how I want it, with cool new keywords, all my utility stuff imported, whatever per project stuff that I need, database handles and stuff created and imported all automatically with no boilerplate in just one use line. And I basically have a completely customized setup. So that's it. If you have any questions, I think I have 2 minutes left.
How long it takes for your setup class to load?
It's very fast. The nice thing about Moops and the keyword API in general is it's a lot faster than Devel declare. If you've worked with Moops X declare, it's really slow. I don't remember benchmark numbers off the top of my head, but using Moops was basically equivalent to just using import into directly. Most of it is in pure Perl, and it's very lightweight. And
so it is not. It doesn't use Moops by default, right?
By default, it uses Moo, but you can use it with Moops if you want to. Okay. And yeah, the first project that I used this on, I switched to Moo because I realized it did 98% of everything that I needed anyway.
I heard people complaining that when they use Moops X declare that they can't debug it.
Yeah, it's really, and
because
I mentioned
the lines
this.
are messed up.
Yeah,
I'm introducing new lines and the line numbers.
So that's one problem. It introduces new lines. Keyword simple handles that a little better. It's not perfect, but it will generally report, if not the right line number, then one after it. And there's a few edge cases that I ran into, but it is better about it. You can handle that when you're writing your keyword declarators by just making sure the Perl code that you inject doesn't have extra new lines in it, and that usually handles it. But when you run into deep problems with Devel declare or Moops X declare, they're a bear to debug. I mean, because there's so much C stuff. You have to learn a little bit about the parser API, which I don't know anything about. So when you run into a bug like that, if you're a mostly Perl guy with a little bit of Perl API knowledge like I am, it can be a real hassle. The nice thing about the keyword API is the surface area where your code is injected is a much smaller scope, which makes it a lot easier to track things down.
It's possible to tell Perl which line number is meant afterwards.
There's a way to do it.
There's at least, if I'm evaling code, I can tell him that there's a special
in an
syntax.
eval, yeah. I think that I know I looked into this at one point. I think there's like a compiler directive you can give in a comment, right? But I think that happens before the regular compile phase. So once you're in compile time, you can't do that. But in an eval, you can. I think.
Yeah, there's an opcode.
Yeah, don't quote me on that. But yeah, I know, I did look into that thing exactly, and I ended up abandoning that.
What is the minimum Perl version?
The minimum Perl version for Moops is 5.14.
5.14.
If you just want to use keyword simple, it works back to 5.12. Okay, I'm out of time.
May I ask
One more question.
a little question? Do you know whether someone already uses Moops in production?
It's pretty new. The first distribution was this year, so I don't know. I don't use it in production. I just started playing with it. I'm sure there's somebody out there who is, but it's a fairly new project. It's still listed as experimental, but you might ask Toby about that. He might know someone who's using it.
I think there are people using it in production, but I personally wouldn't.
All right, thank you very much.